Hello, my name is Pierce Brown, and I'm one of the math tutors here at the DLASC. In my previous video, I showed you some of the properties of the logarithmic functions and a couple of identities with natural log. In this video, I want to actually start working some example problems using those properties that go a little more in depth than what I showcased. Consider the expression log x to the fourth plus log y to the seventh minus 1/2 log c. If I wanted to write this as a single expression, I would simply, using my properties of the addition of logs, or the sum of logs, have an x to the fourth and a y to the seventh, divided by, now we can use our property here. Notice that we have a negative sign, but also we have a coefficient in front of our log. So I want to move that to the power or the exponential position of z. And then I'll put that in the denominator of our new log. Since we have a fractional exponent, I'm going to rewrite this. It's log 4, y7, and this is going to be the square root of z. That is our most simplified form. Working another example, this one I'll go step by step, just so you can see what I'm actually doing here. Consider the expression -4 log x plus log y. Now, I can rewrite this expression by moving the exponent to our x, giving me log x to the -4th plus log y. Now that both of these have a plus sign, I can write them as a product. So this is going to be equal to log x to the -4th y. Lastly, since we have a negative exponent, I'm going to rewrite this as log 1 over x to the 4th times y, which is simply log y over x to the 4th. Lastly, I want to point something out here that if I were to expand this, so consider the expression log y to the x to the 4th. How would I go about doing that? Well, I know they're being divided, so I'll start with my top. This has to be positive, so log y minus log x to the 4th. If I keep going, I'm going to have log y minus 4 to the log x, since I brought this exponent to the front of the log expression. And if you notice, this is what we started with. However, I wrote it in a different order just to kind of keep you on your toes, because as we know that the addition and subtractive properties are commutative, so we can change their order around. Now that we've kind of refreshed our skills with logs, let's start looking at natural log. Recall that the natural log of 1 is 0. The natural log of e is 1. And the natural log of e to the -1 is -1. In other words, that these would cancel each other out. With these properties in mind, consider the expression natural log of e to the 1/7 minus the natural log of 5. Using our properties, we know that we can rewrite the first natural log as simply 1/7, since these cancel out, minus the natural log of 5. Well, we know that the natural log of anything is really e to what power is going to equal 5. That's not something you're expected to know off the top of your head, so you would need to use a calculator to reduce this. And this would be your final answer in the instance that this is equal to x. Let's look at another example. 5 to the natural log e is squared. This is going to be equal to 5. We know that the natural log of e to the anything is going to be that power. So this is 5 squared, which we know is 25. Now, consider the expression natural log of x minus y plus the natural log e squared minus the natural log z. Using our properties, we can expand, or rather condense, this entire expression into one natural log. Putting in parentheses down here, we can see that both of these have a plus. So our new natural log is going to be something times something divided by the natural log of z. Also note that this is simply going to reduce to 2. What we would have is x minus y times e squared over z. Further distributing the 2, this is going to be 2x minus 2y over z. The last example I want to look at is another expression in which we are expected to expand the natural log. So consider the expression natural log x plus y over z to the 4th, cube root of. We can rewrite this as the natural log of x plus y, z to the 4th, all to the 1/3 power, since anything to a fractional exponent is going to be equal to the root of that exponent, with the denominator being the index. Of course, we know that the square root is just assumed to be 2. Now, we can use this exponent and move it to the front. So this is going to be 1/3 distributed to our new expression. rewriting this, we notice that in the top we have an x plus y. So our first natural log is going to be natural log of x plus y, parentheses. Now we're going to have minus the natural log of z to the fourth. Expanding this further, this will be the 1/3 distributed to the natural log of x plus y minus, using our property of exponents, we can move this 4 to the front, 4 natural log of z. And this is our final answer.